Number 6, so 6 through 10 are all based on this reaction. Hey, look, it's an exothermic reaction. Maybe that'll show up later. Anyway, the first one is write the equilibrium expression constant for this stuff. And I think that's a Kc, so that's why they're all brackets. So we don't have to worry about doing big P's like we might if it's a Kp. And you remember that it's always products over reactants. So first of all, look for one that has oxygen and SO2 on top. So that's going to get rid of A and B, and then remember that the SO2 is going to be squared, so that's going to get rid of D. So it looks like the answer is C. And you notice they're all gases, so there are no solids that we have to worry about getting rid of. Number 7, which of the following would cause the reverse reaction to speed up? Now, I'm going to be a little bit careful here, and the reason is because when they're talking about how fast the reaction goes, often they're trying to confuse you into thinking that thermodynamics and kinetics can be mixed. They sort of can, but you have to be really careful about that. And the other thing is they're talking about the reverse reaction speeding up. So there's two ways to view this. One is I'm looking through the answer choices, and they're not talking about catalysts or anything like that. We know a catalyst would speed up both the forward and the reverse reaction, so technically that could be a correct answer because they didn't say it doesn't speed up the forward reaction. But all of the stuff they seem to be doing here is all affecting equilibrium. So if we're talking about the reverse reaction speeding up, we're essentially talking about the reaction shifting left. It's a fancy way to say which of these will cause the reaction to shift left. So let's see, adding more SO3. Well, first of all, you notice they're all gases, so I don't have to worry about if I were adding a solid, it would have no impact. But adding more SO, I believe that that's a 3. Let's stop and blow it up a little bit and see. Yeah, it looks like a 3 to me. So adding more SO3 would shift the reaction to the right. That's not what we want. Raising the pressure. Well, if you increase the pressure, it's going to shift to the side where there's less moles of gas because it's going to try to decrease that pressure. And so it's going to shift left. No, actually it won't. Well, yeah, well, there's 2 moles of gas. Over here there's 3 moles of gas. So it's going to shift left. So that might be the answer. B could be. Let's see. Lowering the temperature. Well, that's why I drew the reaction over here, because you remember the impact of lowering the temperature, we can only figure that out if we write energy into one side of the reaction or the other. So I drew the reaction over here. We know that the reaction's exothermic because the sign was negative. So that means it's giving off energy. So the energy is going to be on the product side over here. And so if we lower the temperature, it's going to shift the reaction to the right. So that is not what we want. It is starting to look like B is going to be the answer. Let's see. D, removing some SO2. If I take away SO2, it's going to shift to the right. So definitely B is the answer. Number 8 is a very odd question, I'll grant you. Let's make it a little bit bigger. So in number 8, they want to know if the reaction's Kc is 8.1, are the products or reactants favored, and by how much? Well, one thing that we know is if K is greater than 1, it means it definitely favors products. And the reason is because in our equilibrium expression, which you see on C there, the products are on top. So if the number is bigger than 1, it's got to be product favor. So that right away gets rid of A and B, and we're down to C and D. Now, whether or not it's C and D, it depends on this very, very odd statement, which is how much. Is it strongly favored or is it weakly favored? And that depends on your interpretation. I would choose weakly favored because we've seen Kcs that are 500, 1,000, 1,000,000. So I would choose weakly favored here. Okay, number 9. Which of the following would cause a reduction in the value of the equilibrium constant? So which way are we shifting? Well, one of the things we got to remember is if we change chemical quantities, that is going to shift it left or right, but it's not going to change the value of the equilibrium constant. So for instance, in A, increasing the amount of SO3, well, if we increase the amount of SO3, yes, it will shift to the right, but it's not going to change the equilibrium constant. So the only thing that would affect it is temperature. And you remember, to do temperature, we've got to, so the answer is going to be C or D, but in order to do that, we got to add our energy back in. And you remember that, actually, I'm just going to put a big E here, that it depends on what we're doing. So let's see, raising the temperature. If we raise the temperature, the reaction will shift to the left. And if it goes back towards reactants, K will definitely get smaller. So I think the answer will be C. If we look at D, if we lower the temperature, if it goes down, the reaction will shift to the right, and that'll be more towards products, and K will get bigger. So if we're looking for a reduction in the value of the equilibrium constant, I think the answer should be C. 10 says, how would raising the temperature of this reaction affect the value of delta G? Now, you might think about this in terms of how would it affect K, because we just sort of talked about that. If the energy is on this side, because it's an exothermic reaction, right, if we raise the temperature, the reaction will shift back, and what will happen to K is K will become smaller. And the other thing is the reaction will become less spontaneous, or less favorable in the forward direction. So if it becomes less spontaneous, that tells us right there that the delta G is going to become, well, you got to remember what delta G is. Delta G, if is negative if it's spontaneous. So if it's becoming less spontaneous, it's going to be becoming more positive. So definitely our answer choices, I think we're going to, of all of them, I think A is more positive. Any others? Let's see. Well, let's look at A. Delta G would become more positive as the reaction becomes more thermodynamically favored. No, I don't think so, because it's shifting to the left, and so it's going to become less thermodynamically favored. Delta G would become less positive as the reaction becomes less thermodynamically favored. That can't be it either, because it's becoming more positive. C, delta G would become more negative. That's not true either, because that's more spontaneous, and we're saying it's going to the left. Delta G would become less negative, which is like saying more positive, as the reaction becomes less thermodynamically favored. Boy, odd wording choices, but D is definitely the correct answer, because we're shifting backwards. Delta G is becoming less negative, because negative is spontaneous, and we want to become less spontaneous. So D should be the answer.